What's up, guys? We're going to continue chapter 9 here, looking at section 6, where we're going to learn about something called the quadratic formula. Quadratic formula is used to find the solutions of any quadratic equation. So, notice here I have a quadratic equation written in standard form, and a doesn't equal 0, then this is true. So copy that big, ugly behemoth down. Notice that x is equal to the opposite of b plus minus radical b squared minus 4ac divided by 2a. Now that looks like a really, really ugly thing, and it is. It's probably one of the handful of things in algebra that you should commit to memory just because you have to use it a lot from this point on. In Algebra 2, you'll use it a lot. So the way these plug in, you literally just plug them into this. And then you solve for the x values. Now we'll talk about how we handle this, particularly the plus minus, with an example in just a second. But first, in school, pencils plus desk equals that guy. Oh my goodness. All right, so using the quadratic formula, it says what are the solutions of x squared minus 8 equals 2x. The first thing that we need to do is get this into standard form. So I'm going to subtract 2x from both sides, and I'm going to come over here where I have a little bit more room. So I have x squared minus 2x minus 8 equals 0. Now from here, I'm going to be using the quadratic formula for this, so I'm going to go ahead and plug in these values. You should have that in front of you. First thing is negative b, so I'm going to have negative and then put this, my b value, in parentheses plus minus, and then I have this big long radical. I'm going to have b squared minus 4ac, which a in this case is 1, and c is negative 8. And then this whole thing gets divided by 2 times a. And that's nasty. But it's really not too bad. Let's go ahead and start doing some of this stuff. First of all, I need x equals. All right, so x equals, the opposite of negative 2 is 2. And then I have plus minus. And then here I have, let's see, we could do some of this in mental math really, really easily. I have negative 2 squared is 4. And then negative 4 times 1 is negative 4, times negative 8 is 32. All right, so positive 32. This becomes 4 plus 32 over 2, which means x is equal to 2 plus minus radical 36 over 2. I need to come over here so I have a little bit more space. So now x is equal to 2 plus minus 6 divided by 2. And the way this works is this sets up two problems. So I have x equals, when it's 2 plus 6 divided by 2, or 2 minus 6 divided by 2. And from here you should be able to do this with mental math. So 2 plus 6 is 8. Divided by 2 is 4, or over here 2 minus 6 is negative 4, divided by 2 is negative 2. All right, so the solution to this equation right here is x equals 4 or negative 2. Now I know that looks kind of ugly. This isn't the best way to solve this problem, and we'll talk about picking a method in a minute, but right now the focus is just inserting it into the quadratic formula. All right, so you just work through it. Make sure your work is neat. That's going to be the big thing. None of the particular math steps are difficult, but if your work is sloppy, it'll be really easy for you to make mistakes in your steps. So here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, here's what I got. X is equal to 7 or negative 3. Hopefully you got the same thing. Let's keep moving. All right, so finding approximate solutions. It says in the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by the equation y equals negative 400x squared plus 0.84x plus 2, where x is the horizontal distance in meters from the athlete and y is the height in meters of the ball. How far from the athlete will the ball land? So if I think about this in terms of a picture, All right, he throws it, and the ball is going in the air, and then it's going to land on the ground right here. So I have the athlete starting here, throws the shot put, and there's my picture. I want to know when it's going to cross the x-axis. In other words, I'm looking for the zeros. So we could approximate this by just substituting first this into the quadratic formula. So I get x equals negative 4 plus minus 0.84 squared minus 4 times negative 4/100 times 2. This is why I'm so glad I live in the calculator age. 2 divided by 4/100. And then we just work through this whole thing. So I know it's ugly, but it's not the worst thing in the world. So I get negative 0.84 plus minus. Underneath this, when I multiply and add all these things together, I'm going to skip a step, but you could do that in your calculator. Please do. I get 1.0256 all divided by negative 0.08. Then x equals negative 0.84 plus minus this big nasty thing. I could do this on in my calculator. I'm just going to leave that in the radical on my calculator. So I'm going to have plus this on one side divided by negative 0.08. And then on the other side, I have x was negative 0.84 minus radical 1.2056 divided by that. And when I run these out, this first one I get x equals negative 2 1600ths. On this one I get about x is approximately 23.16. So I want to know how far away it's going to land. Well, if I'm looking at my two answers, it can't be this one, right? Because that's behind him. That's negative. That's not what I'm looking for. It must be that, because I need a positive answer for it going in a positive distance. All right, so we could say that the ball will land about 23.68 meters away. I know it's kind of confusing, but again, it's just plugging it into this formula. So hopefully you have that written out well in your notes. Let's keep going. Choosing the appropriate method. You'll want to pause and copy this down. The different methods for solving quadratics and when to use them. You want to use graphing. Remember, that's when it crosses the x-axis. Use it if you have a graphing calculator handy and you could just do x-intercepts. That's the best time to use that. Square roots, when the equation has no x term, the b term is gone. In other words, it's like 4x squared minus 15 equals 0. Then use square roots. Factoring you want to do if the equation can be factored easily. In other words, you know the factors by heart because you did your multiplication tables when you were younger. Completing the square you want to use when a is equal to 0, but it's not easily factored. And the quadratic formula is really kind of used for when all else fails. If the equation can't be factored easily or it can't be factored at all, we would put it into the quadratic formula. All right, so here's a few examples to make that a little bit more specific. So if I'm picking a method for each one of these different things, this first one, 3x squared minus 9, I would use square roots because there's no b term. For this one, I would use factoring because it can be factored easily. I need two factors of 30 that have a difference of negative 1. Well, how about negative 6 and 5? There, I did that with mental math very, very quickly. If I'm using this one, I'm going to use the quadratic formula because a is not equal to 1. If I'm factoring this one, I can't think of any factors of 3, so on this one, I'm probably going to do completing the square. I could also use quadratic formula. And then this one down here is really big and ugly. I'm definitely going to use the quadratic formula on that. And this is probably the order in which you want to check things. Can I use square root? Nope. Can I use factoring? Nope. Can I use completing the square? Nope. Can I do quadratic formula? That's kind of the last one to pick from. So make sure you have that copied down just as a quick example for you to refer to. And the discriminant. Okay, the discriminant is the expression under the radical sign in the quadratic formula. You use it to figure out how many real number solutions it's going to have. If the discriminant's positive, there's 2 solutions. If it's 0, there's 1 solution. If it's negative, there's no real solutions. This has to do with the way it's graphed. Positive means that the graph's going to look like this. If it's 0, it means it's going to just touch the x-axis. And if it's negative, then that means it never touches the x-axis. All right, so that's what the discriminant tells us. So how many real number solutions does 2x squared minus 3x minus 5 equals? Well, first of all, let's get it in standard form. And then all I'm going to use is that b squared part minus 4ac. And I could do this very quickly. So I get 9 minus 4 times 2 is 8 times 5 is 40. So that equals negative 39. So how many does it have? 0 solutions. All right. Very quickly I'm able to determine that because, again, this is a negative number. All right. So one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, because the discriminant is positive, it means that this particular quadratic formula would have 2 real solutions. All right, so that's a useful thing that we could use the discriminant for, and a lot of them you could use mental math to figure it out. This one's a little bit bigger, and you probably need to write it out. But generally, you could quickly find out how many solutions you should have. And that's it for today. I know some of that was kind of complicated. Hopefully you took good notes, wrote out the formula really, really well. Probably want to highlight it or, bend the corner of your page down so that you could refer to it very quickly. The quadratic formula is very important. You'll probably have to refer to it a lot. So you want it written down well in your notes. That's it for today. I will see you all in class.